in this session we will study dimensions, and this is the last part of that chapter, units and measurement. Now what is dimensions and how these dimensions are used for various things that we will see in this session. Now length has the dimensions, say L, mass as m, time as t, electric current, then thermodynamic temperature, luminous intensity, etc. Now look at this board. The dimensions of a physical quantity are the powers or exponents to which the base quantities are raised to represent that quantity. Now this definition also you have to learn as it is. Don't add a single word or don't delete a single word, because it changes the meaning of that definition. So whenever we raise the power of the basic physical quantity, then that is called the dimensions. Now using the square brackets around that quantity means that are dealing with the dimensions of the quantity. Now let us see here. The volume occupied by an object is expressed as the product of length, breadth and height, or it is nothing but three lengths. So hence the dimensions of volumes are L into L into L, L cube, right? So here there is no mass and time. As the volume is independent of mass and time, it is said to possess zero dimensions in mass and time. So only three dimensions in length. So sometime m raised to 0 it is written, t raised to 0 and l raised to 3, or simply l raised to 3. Now when we see many examples we will understand it better. Now for example, the force, which is the product of mass and acceleration, it is written as mass into acceleration. So acceleration you have to break down. Means what is acceleration? It is the distance, that is the length, divided by time square. Alright, rate of change of velocity, that we call as acceleration. So the dimensions of force as mass is written as m. There is no L or T, or one can write L raised to 0, T raised to 0, m raised to 1, and acceleration as L raised to 1 divided by T raised to 2, or that T you can take up, means using the laws of indices we can write m L T raised to minus 2, right? Thus the force has one dimension in mass, one dimension in length and minus 2 dimensions in time. So the dimensions in all other base quantities are 0. Means we don't need to express force other quantities. There are so many other basic quantities are there. We have studied the SI system. And my advice to all of you is this: don't by heart this. Means don't rut it. This is for acceleration, or this is for pressure, this is for force, like that. You should know the basic formula. From that you have to generate it, or you have to derive it. If you do it directly, then you have to remember a lot of things and there may be mistake. So you should know the formula for the force. For example, in this case, force is equal to mass into acceleration. Or suppose you want pressure, so force upon that you have to compute, or that you have to calculate over there, and then there will be no mistake. Otherwise it is very difficult to remember all these quantities and difficult to recollect from the memory, right? So this is something about the time. What is meant by dimensional formula? The expression which shows, now look at this board, the expression which shows how and which of the base quantities represent the dimensions of a physical quantity is called the dimensional formula of the given physical quantity. For example, the dimension formula of the volume is m raised to 0, L raised to 3, T raised to 0. So this is called the dimensional formula. And that of speed or velocity as m raised to 0, L raised to 1. Sometimes 1 is not written, it is understood. T raised to minus 1. Now what is this velocity? Velocity is equal to distance upon time, right? or rather displacement upon time. So there is no mass, so m raised to 0. L is in the numerator and time is in the denominator. So L raised to 1, t raised to minus. Similarly, a dimensional formula for acceleration as m raised to 0, L raised to 1, t raised to minus 2. You should know the basic equation or the expression, then you can easily find out. And for mass density, means as we know that density is equal to mass upon volume. So mass raised to 1, right, and volume is L raised to 3, but it is in the denominator, so L raised to minus 3, and as there is no time, so t raised to 0. So mass density is represented as m raised to 1, L raised to minus 3, t raised to 0. Okay. Now, the equation, look at the board, an equation obtained by equating a physical quantity with its dimensional formula is called the dimensional equation of the physical quantity. Look at this. V is equal to, actually on the left hand side we write that physical quantity, and right side we write the dimensions. So m raised to 0, L cube, t raised to 0. Just now we have said, or the velocity, or the force, or the density. So dimensional equation, dimensional formula we should know carefully. And as I just now told you, remember the basic equation or the basic formula, then it is very easy to find out, like how we write the density, that is the mass upon volume, how we write the pressure, that is the force upon area, like that, or force is equal to mass into acceleration. Now, what is meant by dimensional analysis and its applications? Now, first application is checking the dimensional consistency of equation. Now look at it. Now we can test the dimensional consistency or homogeneity of the equation. Homogeneity means whatever different quantities we used in a given expression, whether they have same dimensions or not. If dimensions are different, then we cannot add them, subtract them, divide them, like that. And whatever expression we handle or we write, what is the actual meaning of it? For example, this is the famous equation. Now, from earlier standard, you know that V is equal to U plus AT, like that, or is equal to UT plus half AT square. This is the more general form. X is equal to, means distance is equal to x0 initial plus v0 t plus half AT square, where a is the acceleration. Now for the look at the description of that expression. For the distance x traveled by a particle or a body in time t, which starts from the position x0 with its initial velocity v0 at time t0 and has uniform acceleration a along the direction of motion. Now dimensions of each terms are written as. So we have to write down the dimensions of each term and check whether it is consistent or not. So x is the distance, so we write as L. x0, that is also distance, the initial distance, so that is also L. v0 into t, so v0 is the velocity, as we have mentioned here, it is the initial velocity. So its dimensions are L raised to 1, t raised to minus 1, look at that expression, and small t, that is again time, so that t raised to minus 1 and t raised to 1 they cancel out, and simply L is left. Similarly, half AT square, half is a constant, so keep it aside. A, acceleration, how we write acceleration? L t raised to minus 2 and t square as t raised to 2. So that t raised to minus 2 and plus 2 will cancel out. We use here laws of indices. So finally we get the L. So thus this entire expression is consistent, or we can say that we can test the homogeneity of this equation. So everywhere, see, x is equal to x0 plus v02, there are so many terms. On left hand side it is x, the right hand side, three terms are there, x0, v0t and half AT square. Each is showing you the value or the dimensions as L. So we can say that the expression is dimensionally consistent. Now, next application is deducing the relation among the physical quantities. Means if the relation between the we have to derive the relation between the physical quantity, this dimensional analysis is useful. Now consider a simple pendulum having a bob attached to a string that oscillates under the action of the force of gravity. Suppose that period of oscillation, period means time needed for one oscillation, that we already know. T, capital T, of the simple pendulum depends upon its length, means this is the given or your data, mass of the bob, m, and acceleration due to gravity. Now derive the expression for its time period using the method of dimensions or dimensional analysis. So consider the dimensions of both the sides. Now first we will write that equation. T is equal to, or rather T is proportional to L, G and M. So write the mathematical expression. Now we know that x is proportional to y, means x is equal to some constant into y. Similarly here T is equal to some constant k, L raised to x, G raised to y, M raised to z, because we do not know what is this x, y or z, and that we are going to find with the help of this dimensional analysis. So T, left hand side T, we can write as L raised to 0, M raised to 0, T raised to 1. It is time. On the right hand side, keep aside that k, it is a constant, and that constant cannot be determined with the help of this dimensional analysis, and later on we shall see that from knowledge of that expression of T. Capital T is equal to, that constant is 2 pi. Anyway, so on the right hand side, see L raised to x, right? So L is length, so L raised to 1 raised to x. G, acceleration. Now how will write acceleration? Just now we have seen L raised to 1, T raised to minus 2 raised to y, because here y is our unknown, and that we are going to find. And M raised to 1 means mass, because in the expression it is given that time period is proportional to the mass of that ball. So mass is represented as M raised to 1 raised to z. Now solve this. Equate the dimensions on both the sides. So use the laws of indices. L raised to 1 into x, then L raised to 1 into y, that is y. So finally it becomes L raised to x plus y. T raised to minus 2 into y, so T raised to minus 2y, and M raised to z. Now look at left hand side and right hand side. L raised to 0 on left hand side, right hand side it is x plus y. M raised to 0 on left hand side, M raised to z on the right hand side. T raised to 1 on left hand side, and T raised to minus 2y on right hand side. So equate this and solve this. You get x plus y is equal to 0, minus 2y is equal to 1, and z is equal to 0. So first two equations you can solve, means minus 2y is equal to 1. So y is equal to minus half, means 1 by 2, minus 2 will go on this side. Now put it in that first equation, so that you will get x is equal to half, y is equal to minus half, and z is equal to. Thus we get the expression T is equal to k into L raised to half and G raised to minus half. So you know that formula is T is equal to 2 pi under the root L by G. Like that we can find out the expression for this formula. So this is something about the dimensional analysis. Now in our exercises, so many exercises are given. So we have to solve all these exercises very carefully. And as I told you in the earlier lecture also, or earlier session, you have to take a lot of physical effort. Physical effort means simply by taking the notes or that book or the material and lying in the bed will not solve your problem. Means it will not be the correct preparation. You have to sit down, take the pen, paper and solve it. Write down that whatever exercise is given, then solve it using these 3 sessions. In the first session we have seen units, then significant figures, and this third is the dimension. And carefully you have to solve that each and every numerical. Don't skip. Means what happens is that some students solve only few problems and others they leave it. No, you have to solve each and every exercise. Then only you will get the good practice. So you have to take a lot of efforts, and your final performance or whatever grades or marks you will get, it depends upon how much efforts you have put on. So your marks or grade is directly proportional to your efforts. So you have to take the efforts, means solve all those things carefully, and then only you will get good grade or good marks. And in these sessions, important point is this: for pressure or force or acceleration, you should know the basic formula. Don't by heart or don't do that dimensions directly. You will be in trouble, or you may be in trouble, because while writing, if there is any small mistake, then everything will go wrong. So develop it from the basic formula, right? So for today's session, we will stop here.